Hi everyone, this is your math guru. In this video, I'm going to show you if the following pair of straight line equations are parallel, perpendicular, or neither. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first example, we have y equals 2x plus 4 and y equals 2x plus 9. For a straight line, the standard equation is y equals mx plus c. Your m is your gradient or the slope of the graph, while your c is your y-intercept. So therefore, if you have two lines AB and line CD, the gradient of AB, if it's equal to the gradient of the line CD, what that means is those two lines are parallel or parallel. However, if the gradient of line AB multiplied by the gradient of line CD is equal to -1 or -1, then we say that the two lines are perpendicular. So going back to my first example, if I write the equation of a line, I have y equals mx plus c. The coefficient of x is the gradient. If I tag this as my equation 1 and my equation 2, for equation 1, the gradient m of equation 1 is equal to the coefficient of x, which is 2. And likewise, for equation 2, the gradient, which is also the coefficient of x, is also 2. Note that the two gradients are the same. That is, I have m1 is equal to m2, which is equal to 2. And because the gradients are the same, what that means is the two equations are parallel. Let's look at the second example. In my second example, I have y equals 4x plus 3 and y equals minus x plus 3. Like I explained earlier, the standard equation of a straight line is y equals mx plus c. And to determine if the two equations are parallel, perpendicular, or neither, you need to compare the slope or their gradient. So if I write that formula, mx plus c, and I have my equation 1 and my second equation, equation 2, what it means is in equation 1, the gradient m, which is also the coefficient of x, that's m1 is equal to 4. In equation 2, the gradient m2, the coefficient of x, is -1. So what that means is you can see that 4 is not equal to -1. Therefore, the gradient m1 is not equal to gradient of m2. That means I've removed the possibility of them being parallel. If I do a check and see is m1 times m2 equals to -1, my check is I have 4 times -1, which is not equal to -1 because 4 times -1 is -4. This will give me -4. Therefore, this equation is neither parallel nor perpendicular. It's parallel, not perpendicular. Let's go to the last example. In my last example, I have the two equations, y equals minus 2x, and the second equation, y equals half of x. Going by my standard equation, I have y equals mx plus c. C in this case is 0. So if I go to check equation 1, the gradient m, which is the coefficient of x, is equal to -2. And likewise, for equation 2, the gradient m2 equals to half. So my first check is to check if they are parallel. m1 is not equal to m2. So therefore, it's not parallel. If I check if it's perpendicular, I need to show that m1 times m2 is equal to -1. So my check is m1, that's -2, times m2, 1 over 2. If I do the calculation, minus 2 times half will give me -1. And what that means is, therefore, the two equations are perpendicular. Thanks for watching. Bye.